Hello everyone and welcome to the episode 26 of the Mobile Networks Overview course. In this episode, this is a very short introduction and a brief introduction to NFV in Network Function Virtualization and SDN, Software Defined Networking. This is just an overview, and hope it would be useful for you. Okay. Nowadays, IT and telecom are approaching together, and this is a big challenge because IT experts are not very familiar with telecom area. Also, telecom experts have the same problem because they know they are familiar with some terminologies like signaling flow and telecom protocols and protocol stacks and something like that. And IT men they are familiar with servers and IP network and so on. So this is the challenge, but also a new opportunity. So let's see what's the opportunity. Let's have a let's start with NFV. NFV is network function virtualization. It means that network and the two layers after the first layer, which is data link and network layer in OSI and TCP/IP, will be implemented in the software level, and it would be lead to service agility. The whole system will be very agile and quick, operational efficiency and cost reduction. For example, in service agility, deliver services in second, minutes, that you will see some real case in the next slides, and not weeks and months. Design and launch new services in weeks. Operational efficiency, on-demand service selection and delivery. The service delivery would be very fast. Automation of network operation, and at last, cost reduction. Standard hardware, high resource utilization, and multiple vendors. So what are the NFV market players? The key players. Okay, we have some web scale companies disrupting the market, like Google, Amazon, Microsoft, Facebook. These scales the market, and also some communication service providers, many big mobile operators like AT&T, Bell, Vodafone, and so on. And it is the ecosystem that these players change the way and lead the industry to a new horizon that will lead to service agility, long service introduction cycles, accelerate innovation, and customized solution and customer experience. So what are the NFV drivers and the history of virtualization? One of the drivers of virtualization was movement to cloud. As you know, from some years ago, the interest in cloud was become very increasingly, and also new business service, capex saving, because when you implemented NFV in your industry, many costs will be saved. For example, from power consumption to many other things. Vendor independence, because in many cases you have a software you will install in the virtual machine or some other else, and the maintenance will be very easy in comparison to the past. Lower operational cost and barrier of entry. So these are some benefits of virtualization. quick provisioning, the agility and quickness of the service is really high in comparison to the past. Low operational overhead and costs, improve server utilization, flexible growth. The scalability is very good in this system. Reduce cost of ownership, reduce space requirement. This is very important. For example, I myself remember that for a server there were several racks, for example for a MSC server or something like that. But right now it is a server, very low space, very low power consumption, and this is very efficient. Okay, higher availability and business resiliency, easy management for servers and applications, which is very good for any business. This is it will create operational flexibility. You can see NFV network function virtualization, software defined networks, and open innovation. This has some parts common together. So because of that, many of us don't know the exact borders between them, but I will discuss in the next slide and we will find that. But I think we cannot divide these benefits, but we can assign these benefits to all of this. But let's see what are the benefits. Reduce capex, opex delivery time. I think it's correct for all of them. Reduces space and power consumption, also correct for all of them. Creates competitive supply of innovative application by third parties, and creates control abstractions to foster innovation. And here you can see this is also good. This is a good definition. NFV function programming. The common part between NFV and SDN is software installation, which is very correct. Yes, both of them are focusing on softwareization, but in different levels of TCP/IP and OSI, which you see later. The main between SDN and cloud API are common, and SDN is network programming, cloud resource virtualization. Okay. Here is the very good slide. Sorry, I made a mistake in some slides before. I told you that the NFV is on the layer 23. It was SDN. Do you see? I think this is the best definition for SDN and NFV which I ever seen. And make it clear for us that what is SDN exactly and what is NFV. SDN, as you can see, this is the OSI. This is OSI model, which you know all of them, which contains of 7 layers. If you want to know more details about OSI and TCP/IP, there are couples of good videos on the YouTube that you can watch. But as long as I think you are watching this video, I think you are familiar with these topics. As you can see, for SDN, the focus is to do softwareization for the layer 2 and layer 3, which are data link and network layer. Okay, optimize network infrastructure such as Ethernet switches, routers, and wireless access points. OSI layer 2 and 3. So when we are going to do softwareization for functions in layer 2 and 3, for example routing and some other things like that, the name is SDN, software defined networking. But when we focus on the softwareization of the layer 4 to 7, which are transport, session, presentation, application, or briefly in the TCP/IP in the application layer, this is NFV, or network function virtualization. So you can see that the main focus of NFV is on the top layers. in the opposite side of the SDN, which focuses on the lower layers. Optimize NFV optimize deployment of network functions such as load balancer, firewall, WAN optimization controller, deep packet inspection, and all of the examples in layer 4 to 7 in the top layers. So we can see that in the cloud area with SDN we can move to the network, and the network with NFV we can go through the cloud, create and expose virtual private networks, and also create and manage virtual network functions, scale the network, scale the business. And here we can see that for many various application A, B, C in a data center, it is very right now very unified. Some servers, just one server, and some applications can run on the virtual machine, and it will reduce the cost, power, the area, everything. So when NFV, you can see this is divided, the applications are divided into some parts. Now means it is necessary, never. It means that it's not applicable for these applications, maybe, and yes. You can see for some applications like fiber to the X, fiber to the home, everything RF coherent, RF radio frequency coherent optical, and CMTS. This is not applicable NFV. For core routers and 100G plus switches, because you know this is very critical, so NFV is not recommended here. But for something you can see here, media servers, content delivery networks, packet gateways, control plane functions, network applications like IMS IP multimedia system, which I've explained for you in the previous two episodes, analytical platforms, and EMS, NMS, and NFV SDN control. You can see that we can use and benefit from the advantages of NFV. Some other applications that can be done, but not as necessarily of these ones, are media gateways, network applications, charging application, OSS, BSS, and CPE. And the difference is very clear, because as much as the criticality and importance of the service become higher at this level, at this time that I'm describing for you, it is recommended to not use the NFV, and because of that, for example, for some thing like this, it is not recommended. Also, maybe for the edge routers and the radio access networks, it can be applied. I also see in the industry, for example, for some RNC, I see that it is right now implemented in the real network VRNC, virtual RNC, which is a very promising paradigm. Okay. So when and what and why SDN? SDN, as I told and described for you, is have a focus on the lower layers for automatic optimized IP networking and transport. You can see here the applications is related to network applications. So the essential business value of SDN and NFV are reducing the CapEx, OpEx infrastructure, OpEx application, and revenue. So we can see also some other benefits: hardware flexibility, faster service lifecycle, scalability, leveraging existing tools, agility, operational efficiency, atmosphere service offering, easy validation, vendor independence, and rapid development. You can see here some lessons from the agility, but here is the best lesson that I saw from Amdocs, a lesson from Vodafone. You can see here before implementation of NFV, for an average service provider at a time it takes to launch a new service about 9 to 18 months, which was really high. All of us have saw this. But Amazon service launch frequency right now with the benefit of NFV is just 11 seconds, which is really good and wonderful. So you can see it makes the business very agile, very flexible, and very fast. Before NFV, for an average service provider, for the number of the servers per admin was less than 100 servers, but right now number of servers per admin at cloud data center is approximately could be 15,000 numbers, which is really high, extraordinarily high. This is the very good lessons in efficiency and agility of implementing NFV. And this is the high-level architecture that you can see also in 3GPP documents. You can see there may be hypervisor V1, hypervisor type 1 and type 2 in the lower layer. Type 1 means that the hypervisor is directly on the hardware, and different virtual machines are implemented on that, which is mostly used in the industry. But the hypervisor V2, hypervisor 2 is that this is hardware, this is OS, and then a hypervisor is on the host OS. For example, like what we have in VMware Workstation in our system. For example, we have a Microsoft Windows, and we want to have a Linux on that, Ubuntu for example. So we will install a VMware Workstation, and then on that we install a Linux, a distribution of Linux, whatever it is. Okay, and then on the top layer we have virtual network functions, several virtual network functions. In the vertical part we have NFV management and orchestration, which is mono, which is very important. Operations we have here with OSS, operation system support, and business system support partner, which may be third parties or not. Applications and services, and this is infrastructure services and hardware platforms. This is another high-level architecture that you can see here. These resources can be shared through virtualization, and the resources will share through the different and various virtualized network functions. So you can see that many applications like message routers, content delivery network, deep packet inspection, firewall, SGSN, GGSN, edge routers, BRAS, radio network controller, tester, QoE, carrier WAN, acceleration, session border controllers can go to the area of network function virtualization, and that will bring many benefits for us: independent software vendors, and orchestrated automatic remote install, and generic high volume services, and many other benefits. Here is also another architecture which focuses on the hypervisor. I told you we have two types of hypervisor, type 1 and type 2, which I told you type 1 is mostly used in industry, which means that in type 1, yes, this is also the like the type 1 hardware. Directly after that hypervisor, and in the top layer we have for example some virtual machines and applications. But in type 2 I described for you what is it like. Okay, thank you very much, and I hope it was useful and informative for you. If you like this content, don't forget to subscribe in my channel, and also please introduce my channel to your friends and colleagues. In the next episode, I will have a brief introduction to 5G, and also after 5G I will finalize this series of telecom introductions and overview, and hopefully I will go through the my series of neural networks and artificial intelligence, deep learning, and Python based on that, which is my main passion. Thank you very much, and see you in the next videos.